Hey, welcome to lesson 3 on quadrilaterals. Today we're talking about trapezoids. So let's talk about what a trapezoid is. Okay, trapezoid is a quadrilateral with exactly one pair of parallel sides. So we're going to see two of them, right? The first one fits the definition exactly, where we have just one pair of parallel sides. Okay, this is not what we usually think of when we think of trapezoids, because since like first grade we've been playing with those nice blocks that the trapezoid looks even on both sides. That's because you usually see an isosceles trapezoid, which is a trapezoid with two congruent sides, which we call legs. So it still has the one pair of parallel sides, but now we have those equal legs. So trapezoid, isosceles trapezoid. This is the famous cousin, and this is the lesser known, right? Now, there's some pretty interesting things that happen with trapezoids. First of all, we have one theorem that says base angles are congruent. Now, those parallel sides are our bases. And what's interesting is that people think of just these angles as our base angles, but we have both pairs, right, including these tops, because this is also a base. The interesting thing is that people forget those. They miss them. Okay, so we have two pairs. These bottoms are congruent, these tops are congruent. Our second theorem is that the diagonals are equal. So now it's a little easier if we have some labels. Here are our vertices. Here's our base angles, A and B, C and D. If we connect A to C, and we connect D to B, we would see that those lengths are equal. So, just going off of the definitions of what trapezoid and isosceles trapezoid are, and using these two pretty easy to use theorems, we're going to answer a couple of questions. Like this one. Is this quadrilateral an isosceles trapezoid? Why or why not? Well, they're talking about all angles here, right? And the theorem that we notice says that base angles are congruent. Our base angles are the ones that are attached to the parallels. So these look like they would be our parallels. They look like it anyways. So that means that we should have congruent base angles, which we're good here. But we run into a problem because, as I mentioned, we need both pairs, and these do not match. So is this an isosceles trapezoid? No, because base angles aren't congruent. That's a problem. All right. Suppose AC is 17x minus 40, BD is 8x plus 5. We want to find the length of AC. And they give us a picture to work with. How nice of them. Well, that picture actually says a lot, right? It shows us that we have one pair of parallel sides, and we have two congruent, what we would say would be legs. So we're working with an isosceles trapezoid. So that's useful because we know the diagonals are congruent, and they're giving us diagonals, right? They're asking about one of them, and they give us info about them. So if they're congruent, all we have to do is set those values equal. Okay, we're going to solve for x and then plug in the AC to find out AC's length. Because they're congruent, we just have to set those values equal and solve. Right, so here we go. Subtract 8x. Let's see, 17 minus 8, that would be 9x. Equals 40. I'm sorry, minus 40 equals 5. Let's add 40 to both sides. And then divide by 9. 45 divided by 9 is 5. But that's not our answer, right? We said that we want to find the length of AC. So we've got to plug in x, which we said was 5, into this equation. So 17 times 5 minus 40. Let's see, 17 times 5 is 85. And if we subtract 40, we get 45. So AC is 45 units long, right? Got a couple problems for you to try. So before you do them, right, this is what we thought about. We looked at the picture, figured out the type of shape we were working with. It's probably going to be a trapezoid, right? And then we thought about what they're talking about, and then looked at the theorem or definition that matched. So try these problems out, pause the videos, and then resume when you're ready to check your solutions. Okay, let's see. See if you did it. We want to work with QS, which is a diagonal, and it's an isosceles trapezoid, so we should be thinking about diagonals being congruent. So they give us RT, and they give us QS, and those should be equal to each other. I'm going to add 5 to both sides, and then divide by 4. So let's see, 22 over 4, that's going to reduce to 11 over 2. I'm going to leave it as a fraction because I think fractions are easier to work with. Okay, and that's all that they were asking for was x. If you happen to have given me a decimal, you would have wanted 5.5. So I guess if you got 5.5, you're in good shape there too. Here was the other problem you had. They wanted you to find perimeter. Okay, so you need to use a little bit of prior knowledge, right? Perimeter is the entire outside distance. Now we have an isosceles trapezoid, right? Because it shows us that these sides are congruent. So that's going to be 8 right there. All we have to do is just add up those values. 13 plus 8 plus 29 plus 8. You would have gotten 58. Okay, pretty simple stuff to work with isosceles trapezoids, right? That's it for this lesson. Hey, look at that. We kept it under 10 minutes. If you want, I can extend the video. You guys can watch me have like a battle between this elephant and this alligator. If you want to keep watching. I'm just joking with you. I'm not going to do that. All right. Hey, if you have questions, leave them on the comments. Don't comment on the elephant and the alligator thing, though. It's only a joke. Bring the rest of your comments to class if you have questions. I'd love to answer them there.